quiz. Okay, so it's going to be brief. Yeah. I have already shared the questions we are solving for this tutorial on the platform. I've already shared the questions on your platform. So if you are not the type who visits your platform for information, that is completely none of my business. It's there. So you can access the questions, and then you have the questions as well to just follow along with. So these are the questions. Actually, one of them, not almost all of them, are some form of past questions. The first one is a past question for previous years, which is slightly modified. And the other ones are also some past questions. So by going through this, I hope that you will be equipped to face tomorrow's quiz. Very straightforward questions. But a few things I want to alert you on. That's why I'm conducting this tutorial. So before I start everything, if you have something to say, very brief, you can say it, no time wasting, because I'm supposed to meet the marketing students in few hours time. So this tutorial has to last a maximum of 1 hour. It has to last a maximum of 1 hour. So quick one, just be quick. If you have something to say, put your mic on. Immediately you finish saying what you have to say, put your mic off. Put your mic on, mention your name, and go ahead with what you have to say. Okay, so nothing to say, then let's go ahead. Question 1. I hope everybody can see my screen. Are you seeing my screen? I've shared my screen with you.
Yes, sir.
Yeah, in addition to this, you also have the questions already, and you're supposed to have seen it and downloaded it and even gone through the questions ahead of time. So you can download the question and also follow through it by that means. Question 1 is on EOKO calculation. So let me quickly read through the questions whilst you follow along. Atware Company is a company based in Cape Coast and sells goods solely within the central region. The recently appointed financial manager of Atware Company has been appraising the inventory management system of the company and has gathered the following information. About the inventory policy. The current policy is to order 100,000 units of the product of the inventory. When the inventory level falls to 35,000 units, forecast demand to meet production requirement during the next year is 625,000 units. The cost of placing and processing an order is 250 Ghana cedis, while the cost of holding a unit of the inventory in stores is 50 pesos per unit per annum. Both costs are expected to be constant during the next year. Orders are received 2 weeks after being placed with the supplier. Required. Calculate the total cost of the current ordering policy. 2. Determine the total cost if the economic order quantity model is used. 3. Determine the savings that could be made by using the economic order quantity model. So basically what this question is asking, testing of you, is that you're supposed to be able to calculate the total cost associated with handling inventory based on their current policy. And their current policy is a policy which is not based on the economic order quantity model. It's not based on that model. So the II part of the question is asking you that you should use the information in the question to determine, first of all, the economic order quantity, and then the total costs associated with ordering the economic order quantity. And then you now look at the economic order quantity model and their policy now, which is not the economic order quantity model. Look at the two and see if there is any difference in costs by using the two policies, and the difference in costs is in favor of which one, and which one would you recommend that they do. So this is the focus of the question, which is clear and everyone should be able to understand, because understanding the question is also part of the question. It's a requirement that you have to meet. Okay. So with everybody having the question, whether you have it or not, you should have had it. I posted a question yesterday. Yesterday it was there. And you should always make sure, because you know this thing is going on. Because of the season, most of the things we are doing are online. You should always put your gadgets on to receive alert, at least from these platforms that you receive academic information on. If you decide not to get them ready to be notified of information, there's nothing I can do about that. That is a choice you make. Okay, so let's go ahead with the solution of the question. So we have a requirement to calculate total costs associated with the current policy. Okay, so with your current policy, they order in chunks of 100 units at a time. Anytime they order, they ask suppliers to bring inventory. The supplier brings them in 100 units of the product, 100 units. And they order 100 units each time they want to order when they get a signal that inventory levels are falling to 35,000. So this is the current policy. The order quantity is 100,000. Okay, so they order 100,000. If they do that, what is the total cost associated with it? So the question is asking you calculate the total cost of the current ordering policy. And we know the total cost framework already from our previous lectures. Sorry. Okay. We know that total cost of handling inventory is equal to annual ordering cost plus annual holding cost. In this particular case, from the question, purchase cost per unit will be constant. So that information was not even relevant. They didn't even bring it. So we do not have to deal with purchase cost. If there is a case where purchase cost will be different across different order quantities, then we have to calculate the total purchase cost as part of the total cost. So for this particular question, this will be the total cost of model that we have to work things through. The order size or the order quantity for the current policy order quantity is equal to 100,000 units, and annual demand is equal to 625,000 in the question. It says forecast demand to meet production requirement during the next year, 625,000. $625,000. So we can get the number of orders that will happen in the period. We order in size of 100,000, and by the year, by the close of the year, we should order a total quantity of 625,000. So number of orders that will happen within the year, or the number of times we will order, represented by D over KO, is equal to 625,000 divided by 100,000. 625 divided by 100. That will give us 625 by 100. What would that be? You can calculate, put on your mic and give the answer.
6.28.
6.28.
8.
This is not 628, it is 625.
6.25.
6.25, good. So this is 6.25 times. This is the number of orders. We will order 6.25 times within the year. Yeah, the 0.25 may not make sense because we don't have a fraction. Or the only sense we can make of it is that maybe the last part, the last order may not be up to the 100,000. It will be a fraction of 100,000. That's why it's 6.25. So we order 6 times. 6 times. Each of these 6 times will be 100,000 each. So 100K, 100K, 100K. Each of these 6 times will be 100,000. And the point is not up to 1. So maybe the last order, which will go into the 7th order, will not be up to 100,000. Maybe it will be about 25,000. Maybe the last order will be 25K. So that's the rationale behind 6.25. So this is the number of times we will order. That's the most important thing to note. And each time we order, the order comes with, yes, sir.
Sir, please, so does it mean we'll make it 7 times or we'll still maintain the 6 times?
For calculation purposes, you just use the 6.25, all right? In practical purposes, for exam purposes, use the 6.25. For practical purposes, you can use the 7 because all the 6 times we will order, it will be the 100,000. But when we finish with the 6 orders, we will still have something short of the 25,000, about 25,000. That will go into the 7th order. The 7th order, whether it is 1 unit of the inventory, 2 or 25,000, it will come with the same cost of order. So that will make it 7. All right. But for exam purposes, use the 6.25, the exact figure to calculate.
Okay,
if you make an assumption that 6.25 times, technically, in reality is 7 times ordering, because each of the 6 times you order 100,000, 100,000, 100,000. You can't stop with the 6 times because it will be left with some inventory to bring, which will go into the 7th one. If you are able to write something like that, based on which you will say that the number of times you will order is 7, I will mark it. That is intelligence. But if someone goes really according to the figures and calculates, that is equally right.
Okay,
so your question is a very beautiful question. Okay, so we know the number of times we will order, and then we know the costs for an order is equal to 250 Ghana cedis. So each time you order approximately 7 times, each time you order, we incur this cost. And we order this number of times in the year. So calculating the total or the annual ordering cost in a year is very logical, it's very commonsensical. I will order 6.25 times, and each time I order, I will pay 250 Ghana cedis. If someone uses 7, so this approximately 7 times. Yes, it's 7 times 250. But let's use, for mathematical purposes, let's use the 6.25. If someone uses 7, because we even if the last order is not up to 100,000, it's still an order which will go for 250. Actually, 7 times order. That will be more intelligent. So annual ordering cost will be equal to the number of times we will order.
1,750.
Number of times of ordering times costs per order. Number of times of ordering, let me repeat it here. Number of times for ordering in the year times cost per each order. And this will give us 6.25 times 250 Ghana cedis. That will be, repeat the figure for me.
1,562.5.
1,562.5 Ghana. Points what?
0.5 Ghana cedis.
Okay, 0.5 Ghana cedis. So 1,562 cedis, 50 pesos cedis. That's the total ordering cost for the year per annum. Then let me go back. We are using this framework. So we are done with this. This is equal to 1,562 cedis, 50 pesos. Annual ordering cost. We have to calculate this one as well. We have to calculate this one. So annual holding cost is equal to cost of holding 1 unit of the inventory times average inventory. Average inventory, denoted by Q/2, is equal to, we are still working with the old policy where they order 100,000. That figure is arbitrarily determined. They just say 100,000. It's not based on any scientific means. So 100,000 divided by 2, which is equal to 50,000 units. So that is average inventory. Let me clear this one. That is average inventory. So annual holding cost is now, whose formula is Q/2 times cost of holding 1 unit of the inventory is now equal to 50,000, which is the average inventory, times, let's see from the question, holding cost per unit.
50 pesos.
50 pesos, good. Times 0.5, which gives us 25,000. 25,000 Ghana cedis. So the whole year we will incur a total holding cost of 25,000 Ghana cedis. And you know it simply as the sum of the annual holding cost and the sum of the annual ordering cost. That gives us the total annual cost for dealing with inventory at that level. So total annual costs of dealing with inventory. We are still on the old policy. That will be annual ordering costs of how much, please? 1,562 cedis, 50 pesos. Annual holding cost of how much? Of 25,000. And the sum of the two gives us total cost. What would the sum be?
26,562.50 pesos.
26,562.50
pesos.
0.50 Ghana cedis. Good. So this will be the total cost. Or this is the total cost that the company, that Achere company, will be incurring as inventory costs if they stick with their old policy of ordering 100,000 units each time they order, with 250 Ghana cedis as the cost per order and 50 pesos as the cost of holding 1 unit of inventory for the year. If you go back to the question says, or even without a question, we know from our studies that they can do better. Or at least, let's see, what if they use the scientific way of managing inventory? What if they use that approach? Will they have an improvement upon this one? And in theory, that is what we will argue they do. They should do it on a scientific basis. They should use the economic order quantity modeling to do things. But they are just doing it their own way. So we want to now use the scientific method to see what the figures should be like. And then we compare the scientific method, the cost that will be generated, to their method, which is not based on scientific method. So we now go to requirement II, which says determine the total cost if the economic order quantity model is used. This requires you to first determine the economic order quantity. If you get that quantity, that could be something different from 100,000 as their old policy. If you get that one, you come to calculate the total cost using that kind of quantity, and then we can compare to see if there are any cost savings going the scientific way or not. Okay. So now scientific. So let's see. Let's open another page. Let's call it scientific approach. And what I mean by the scientific approach is the economic order quantity modeling. Economic order quantity model. That one, EOQ, is determined as 2 times cost per order times D. And you have to understand multiplication is commutative, so the 2 can even come at the last. That's not the picture. That's not the point. Okay, so this is what it is. And based on the information we have from our Achere company, this will be 2 times cost per order is 250 times demand, annual demand. And this D is annual demand. And that's one of the reasons why I'm even doing this tutorial. I have to clarify something on that. Yesterday, one of the serious students came to me on that issue. That's the more reason why I'm doing this tutorial. So annual demand is 625,000, all divided by 0.5 Ghana cedis. Okay, so do the evaluation and give me the answer. Let's evaluate them one by one. 2 times 2 times 250 times 625,000. What would that be? Just point your calculators, please. 2 times 250 times 625,000. Hello? Be quick.
Yeah, sir.
What's the answer?
So you 312,500,000.
Read them individually. 2
3125
125.
00000 5 zeros.
How many zeros? 5 zeros.
5. Yes.
Okay.
Sir.
Okay. Divided by 0.5. Okay, so divide that one by 0.5. What would we get?
17677.6.
17677.62. Is that right? Is that what it is? I'm asking.
Sir.
Can't you speak? Kingsley Body? Kingsley?
Yes, sir. Sir, I found the square root. Yes, I found the square root.
We are solving it step by step, so you can't jump the step. When you evaluate it, what do you get? So give me the right figure. Don't jump the figures. We are following steps. The last step was square root of 312,500,000.
Sir, I was supposed to
and then you divide that by 0.5. What is that value? When you do this, when you evaluate this, what do you get?
625.
625 and 6 zeros.
625.
Yes, and 6 zeros.
625. 1, 2, 3, 1, 2, 3, like this.
Yes.
Good. Then take square root. So EOKO is equal to, when you take square root of this, what do we get?
So 25,000.
25,000.
Yes.
Thank you. The other people, I don't have only 2 people in class. I have for now 22 students. Everybody needs to be participating. Don't just be watching the screen, please. I beg. Okay, so 25,000.
yes, 25,000.
So this is the economic order quantity. The meaning is that this is what they should have been ordering anytime they ask their suppliers to bring goods. This is the quantity they should order. But what was the old policy? For the old policy, what quantity were they ordering? 100,000.
100,000.
Okay, that should tell you that based on our scientific knowledge, what they have been doing is wrong, or is likely to be wrong, because the difference is very huge.
Wrong.
The difference is very huge, 100,000 and 25,000. But let's go ahead. Now with 25,000 as the order quantity, number of orders, number of times we will order. Okay, before I even come to number of times, let me write this. Annual demand is the same. It has not changed. Annual demand, D, is the same 625,000. Number of times we will have to order to exhaust the 625,000 units of the good. We are ordering them in 25,000, 25,000, another 25,000, another 25,000. How many times we will order 25,000, 25,000 so that we will exhaust 625,000? So number of times, 25 times. Number of times to order, denoted by D over Q, is equal to 625,000 divided by 25 thousand, and that is equal to 25 times.
25, yes.
Yes, sir.
25 times. We'll have to order 25 times. And each time we order, it comes with a cost of 250,000. Sorry, 250 Ghana cedis. Sorry. 250,000 Ghana cedis. That's in the question. The cost of placing, I'm reading from here. The cost of placing an order. The cost of placing and processing an order is 250,000 Ghana cedis. So that's the cost per order. That does not change between the old policy and the economic order quantity model. It's the same. So basically what is changing is the order size. Okay. So now the annual ordering cost, or the cost we will incur for the whole year when we order in sizes of 25,000 cedis and with an order cost of 250 cedis will be equal to
6,250
times 250. And that will be equal to
6,250.
Good. 6,250 cedis. 6,250 cedis. Now let's come to the holding costs. Holding costs. We first have to determine average inventory, which is Q over 2 is equal to 25,000 divided by 2, which is equal to
12,500.
12,500.
12,500. Good. So annual holding cost, which is equal to average inventory times cost of holding 1 unit of the inventory. Let me open a new page to do that. Annual holding cost. Average inventory times cost of holding 1 unit of the inventory. This will be equal to 12,500 times 0.5. What would that be?
6,250.
6,250
Ghana cedis.
So you realize that with the economic order quantity model, where the quantity minimizes total cost, you will see that the annual holding cost is equal to the annual ordering cost. Are you seeing that? If you go back, you will see that the annual ordering cost was 6,250. Annual holding cost 6,250. That tells you that on the total cost curve, we are now operating at the turning point, the minimum. This is the only place where we have the two costs, annual holding costs and annual ordering costs, meeting or being the same. So we'll have something like this and something like this. Okay, so this is where they meet and then turn to the turning point of the total cost. So this is holding cost. This is ordering cost. And you have to understand this because we've done it in class. Right. So now that we have calculated the annual holding cost, annual ordering cost, we can go ahead to calculate the annual total cost. And it is the holding cost plus the ordering cost. So let's go to the next page. So annual total cost, which comes in the form of annual ordering cost of 6,250, annual holding cost 6,250. That gives us a total of what?
12,500.
12,500, right? Okay. So this is the cost, this is the total cost that a care company will have to be dealing with if it goes the scientific way, the economic order modeling way, economic order quantity modeling way. The old way, without regard to science, the total cost is the total cost is 26,562. Which of the two approaches yields the lowest of total costs? So
Using the scientific method.
The scientific
economic
method, the EOQ method, right?
Yes, sir.
EOQ method. So now let's see. The last question is asking us to calculate any cost savings if that's the case. So cost savings if EOQ approach is adopted. So we have the old policy. Total cost is, let me do it well. So total costs. So old policy. Old policy was how much?
So 26562.5.
26562.5.
62.5.
Good. 26,562 cities, 50 pesos.
Yes.
Good. EOQ method. What is the total cost?
12,500.
12,500.
What is the difference?
So 14,062.5.
So 14,000.
14.
Yes, and 62.5.
Like this, 14,062.5.
Yes, sir.
Yes, sir.
So that is how much. That is how much we will be able to, or our care company will be able to save if it switches from its old policy to the scientific approach of the EOQ method. Is that right?
All right, sir.
Okay, so that is basically what question 1 is requiring you to do. Question 2, I may not solve everything with you, but I will explain for you. So yes, please.
So in the question they said orders are received 2 weeks after being placed with the supplier. Won't we do anything about that?
What will you do about that? That is not relevant to what we are doing. It may be needed for some other things. So please, this is what I want you to do. That's why I always stress on you understanding the concept. That's a very good question. If you don't really understand the concept, a question can be fraught with many distractors. A question can be embedded with many issues that are not really needed for what it is asking you to do. In education, they call those things distractors. So a lot of information can be there, and they may be needed somewhere, sometime, but the specific thing you are being asked to do now, you may not need it. But if you don't really understand the concepts you are reading, you will be doubting about this because why am I not? You may be tempted to use everything because you don't really understand what you are doing. All right, so that one is needed when we want to calculate the levels. So that the information there is about lead time. All right, that information there is about orders are received 2 weeks after being placed with the supplier. This is about lead time, so the time it takes for the orders to arrive. So if you have maybe an extra question where you are being asked to calculate the minimum level, the reorder level, the maximum level, where you will be required to use the minimum lead time, maximum lead time in any of the formulas, then this information becomes critical. But because any of the requirements here, you are not being asked to do any of those things. That information there is needed, but not for what you are being asked to do for now. Is that right?
Yes, sir.
Okay. Question 2 is a very simple question, so let's go straight ahead. Demand for an item of inventory is 500 units per month. Cost of placing order for items of inventory is 230 Ghana cedis per every order placed. A unit of inventory costs 100 Ghana cedis to purchase, and the holding cost is 20% of purchase cost. Very simple question. What I want to actually explain is this kind of thing. Is this demand, and it is actually this per month, the per month thing there, per month. The formula for EOQ, that's something I need to explain well. The formula for EOQ, which we all know, all right, D is defined as demand per annum, demand per year, annual demand. So if the demand is given in a period other than annual, you will have to scale it up to an annual figure. Demand can even be given for 2 years, or it may even be given like quarterly. And you have to have the knowledge to scale it up to annual equivalent. It can give you demand for 4 years. So 4 years divided by 4 to get annual demand, assuming things happen in a parallel manner. Okay, so that's the main thing. When you get some questions, they can even give you the demand in weeks. And always, unlike this question, when they give you the demand in weeks, friendly questions will try to give you the number of weeks or information to make you get an idea of the number of weeks in a year so that you can scale it up to a yearly equivalent. This one is quite simplistic. We know that there are 12 months in a year. So if it gives you an annual demand of 500, we know, monthly demand of 500, we know the annual demand will be 500 times 12. And the rest is the same as we know. So this is the only thing about it. The formula needs to be understood well. D is annual demand. CO, it has nothing to do with the period. It has to do with the order itself. So this is cost per order. Cost per order. And then CH has to do with the period as well. CH is cost of holding inventory. Cost of holding one inventory. Cost of holding one inventory for 1 year or per year. It also means that if a question can intentionally give you the cost of holding inventory in a month, it can give you the monthly equivalent or it can give you the weekly equivalent. And then you have to scale it up. One student came to me in office yesterday. That's the more reason why I've set this question up to explain that challenge. All right, so for question 2, let's just solve it. It is very straightforward. Let's even solve it here. The question is asking us to compute the EOQ, the cost minimizing order size. So EOQ is given by the formula 2DCO over CH. And we know that this is annual demand. But in the question, it is monthly demand. So we can just calculate annual demand somewhere. Annual demand D is equal to 500 times 12, because there are 12 months in a year. And that will give us what?
6,000.
6,000. Good. And the rest is the same. So we now come and pick the formula. 2 square root of 2 times 6,000 times 230. All over 20% of 100 will be 20, right? Is that correct?
Yes, sir.
Yes. Yes, sir.
Okay. So 2 times 6, 12. 12,000 times 230. Those with calculators should help us quickly.
Sir, 2,760,000.
Divided by 20. Divided by 20 will give us what?
138,000.
138,000. Take square root of that.
So 371.5.
371.48.
371.5.
371.48.
Yes.
Okay, that's okay. You are all correct.
Yes.
So
yes,
EOQ approximately is 370. Let's say 372. 372 units. So anytime we are ordering, we have to make them bring 372 units of the product. That's EOQ. The only thing we are learning is the demand thing. Demand was given to us in monthly form. We have to annualize it because in the formula, D is an annual demand. That's all. Question 3. Adia Penal Company Limited uses EOQ modeling to determine the order quantity for its inventory. The annual consumption of the inventory is, so this one is straightforward. You know, it gave it to you in annual value, annual demand. So you do not do anything about this. The formula stands the same. But in most questions where the examiner wants to test your understanding of how you convert from this to that, the question may be in weeks. Sorry, the demand may be in weeks. Demand could even be in days. And such questions, the question comes with information to do the scaling. All right, I'm sure those who are reading have seen questions of that nature. Okay, so this is where I think we have to end our tutorial. I have been able to highlight the key things that I wanted to highlight. If any one of you has any question, you can ask at this moment.
Okay, any question?
Sir,
Yes, madam. You're there.
please, the reorder quantity.
Reorder quantity.
Reorder quantity. Yes, I realized that in some of the questions, we were asked to find the reorder quantity in the book, the textbook. So I'm wondering what kind of formula we use to find the reorder quantity, because I've been getting different formulas and I don't know which one is the right one. So that is my question.
Which different formulas? At least give us 2 different formulas.
Okay, so I got one to equate the reorder quantity as the same as the economic order quantity.
And that is what it is.
Yes, but you see that some of the questions, they ask the reorder quantity, and then they still ask the economic order quantity that minimizes total cost. So at that particular point,
No,
would you give
that's
the same answer?
the wrong question. Let me say one thing.
Okay.
Let's pay attention. If the question is saying reorder level, all right, I'm writing 3 things. Reorder level, reorder quantity, and sometimes even order quantity. Order quantity or order size. Okay, reorder level is different from these things. Reorder level is the level that if your current inventory hits, you should order new ones to come. But when you are ordering, what quantity would you order? So the reorder level is a signal that, oh, what I have in store now has gone down to the level that I need to bring new one. That's the reorder level. But when you realize the
Okay.
level you have in your warehouse has gone down and you have to bring new ones, the new one they are coming, the new one they are bringing is another order. So they will call it reorder, but it's a quantity. So that's the difference between reorder quantity and reorder level. They are not the same. So reorder quantity is the quantity that if you realize you should order, that they should bring. And it's the same as the order size or order quantity. And if your reorder quantity is determined by scientific means, then we say that this reorder quantity is economic order quantity. So the reorder quantity or the order quantity or the order size can also be synonymous to economic, the EOQ. It becomes synonymous with the EOQ only if you are not arbitrarily determining the order quantity. You understand? If you arbitrarily determine the order quantity, like I was doing, ordering 100,000 units, ordering 100,000 units. The 100,000 unit is order quantity. It is reorder quantity. It is order size, but it wasn't EOQ because it wasn't minimizing costs. I don't know if I have explained your question.
Yes, sir. Yes, sir.
Sir,
Thank
can
you.
you come again?
I can't come again.
Okay, sir.
Please, can you repeat what you said?
Okay, I can repeat what I said. What I said was she asked of reorder quantity and EOQ and other quantity. Once she was asking the question, I got who are the seven? I got a sense of what her problem is likely to be. It's very easy for you to confuse reorder level and reorder quantity. That's why I've written these three things there. It is possible that he was seeing reorder level the same as reorder quantity, but they are different. Reorder level is the level of your current inventory, which you will call your supplier to bring new one. So you may start an inventory with, let's say, 1 million goods. Then you say that, okay, if I'm selling and I sell and the level gets to, let's say, 500,000, I'll call my suppliers to kind of top up. So the 500,000, at which point you call your suppliers to top up, is the reorder level. But when you tell your suppliers to top up, what quantity should they bring? Should they bring the 500 you have sold? Should they bring some other quantity? The quantity that the supplier should bring to replace what you have sold out is the reorder quantity. It is the same as order quantity. It is the same as order size. And I'm saying that if you determine your reorder quantity or order size the scientific way, then that quantity is also called the economic order quantity. But if you just do like Ache is doing, when your inventory levels hit 35,000, bring me 100,000. It wasn't determined on scientific basis. But that 100,000 they were ordering was reorder quantity, was order size, but it wasn't economic order quantity. This should answer your question.
Yeah, thank you, sir. Yes,
okay.
Please.
So this is where we end the tutorial. I have a class, so I'm just preparing to go for that class. Okay, so we'll meet some other time. Thank you. All the best.
Thank you, sir. God bless you, sir.
Easy.